Hi class, welcome to day 2. I'm just making sure we're on. I forgot to see if I pressed record. Yeah, we're recording. All right, so ladies and gentlemen, see if we can get back on here. Hopefully that'll minimize. It should go away. There we go. All right, so I apologize for that, ladies and gentlemen. Here we are on lesson 1.1, relations and functions. Sometimes we will do warm-ups. That's either to take a look at some homework or to go over some necessary steps to get us into being successful into today's lesson. All right, so first of all, we need to take a look at a question you may have had from last night's homework, which is page 2, number 6b, graph, and label the vertex and the axis of symmetry. Now, the problem with this, ladies and gentlemen, is when you take a look at this equation that was given in 6D, it is not in vertex form. So what we need to do is called complete the square, okay? Completing the square is a task or a piece of basic information we learned in grade 10 in the quadratics unit, and we'll go over it to make sure that you understand. Just remember, ladies and gentlemen, in order to graph a parabola, you want to have it in vertex form. And vertex form, if I do the old form, is x minus p squared plus q. However, this question, ladies and gentlemen, is given in the standard form. And the standard form is y equals ax squared plus bx plus c. All right, so what we need to do is what we call complete the square. Okay, and in order to complete the square, we should recognize a couple things. So from the given equation, a equals -1 because it's in standard form, and b equals 6, and c equals 0. Okay, if c equals 0, therefore, what do we know automatically? We know that the y-intercept equals 0, because that's what's special about standard form. All right. So that's one thing we automatically know. So hey, we could plot that right now if we wanted to. Okay? All right. Perfect. All right. Now, in order to complete the square, I'm going to change colors so we don't get confused. The first step, and I'll write this down, step 1 is to factor what we call the term a out of first two terms. Okay, so I'm going to just rewrite my equation from the question first of all. Now we don't have a third term, so this time it's okay. So we're going to factor out a, so it's going to be negative, and then we're going to have x squared. Notice minus 6x, that changes. Okay, then we've got to do some work in the margin. Okay, step 2 is to do b divided by 2 and then square it. Okay, so what's our b value, ladies and gentlemen? -6, because you go with what's in here. So that's our -6. We've got to divide it by 2 first and then square it. So dividing it by 2 is -3. And then squaring that's going to equal 9. Okay, that's the number we need to add and subtract in order to complete this square. So I will add it first, and then I will subtract it. Okay? And again, if you need to review this, there is a good section in the appendix, and I'll go over that. I think it's on page, I'll just write down here, page 564. If you need to practice some more completing the square in your appendix. They're very good about, if you're stuck with something, to go there and check things out. They have a good review there. All right, so the first 3 terms inside our bracket is what we need to complete the square. So what's really in our way is this -9. So we're going to bring it out. When we bring it out, don't forget to multiply it by the negative out front. So what do we end up with? Is our perfect square. Now we've got ready to go there. And when you take negative times -9, that becomes +9. Okay, and the last part is to complete it. So y equals negative x. If you're not sure what it is, you take the sine of the second term and the square root of the third. Or you should realize that it's that exact value right there, squared plus 9. You're saying, great, Mrs. R, we've completed the square, and now it's in vertex form. Well, hey, what do we know? We now know that our vertex is 3 and 9. So let's check that out. 3 and 9. Notice that I'm going up by 2 on my scale this time. All right. And ladies and gentlemen, just remember to plot, you can use your step pattern. A times 1, 3, 5. And this time, A is what? Negative 1. So what is that going to equal? Negative 1, negative 3, negative 5. Let's take a look at that. So from there, ladies and gentlemen, I'm going to go over 1 and down 1. Over 1 and down 1, 2, 3. And over 1 and down 5. Gets me right there. Perfect. Okay, let's try it again. Go from the other side now. Go over 1, down 1, over 1, down 3, over 1, down 5. Okay, so there, ladies and gentlemen, is our parabola. Okay, and again, you needed to complete the square in order to get the vertex. Once you have the vertex, you apply the step pattern to it. Okay, let's put down vertex, which was 3 and 9. And then don't forget to give your equation on label on your graph. All right. Okay. So hopefully you guys have a good understanding of that. Again, if you need completing the square, see page 564. I'll probably reference that in our lesson as well. All right, example B, part B. Use this function here to answer the following questions. So let's just test your understanding of vertex form. Okay, first of all, state the vertex. Just remember, it's the opposite of what you see in the brackets, so it should be negative 4 and 9. Okay, state the equation of the axis of symmetry. Now, we didn't quite go over that, but whenever you have a vertex, x, y, whatever it is, that equals the axis and your min or max value. Okay, so the axis is going to be part of the first part of your equation, and you make it first part of your coordinate of your vertex, so it's going to be x equals negative 4. State the direction of opening. Well, you look at A. A is negative, so it's going to be downward. Opens down. Because A, and this is my short form for negative, right there. So A is negative. All right, describe the transformations from y equals x squared. Remember we discussed last day that y equals x squared is your parent function. So how do you transform the equation from y equals x squared to y equals negative 3 bracket x plus 4 squared plus 9? Well, first of all, let's start by breaking it down. What do each of the characters mean, or the letters mean? So we know A equals negative 3. That tells us two things. It opens down, or reflects the x-axis. I want you to get used to that. I'm sorry, opens, I forgot to put it down. Opens down. Okay, and the 3 part tells us the step pattern is going to make it narrower by 3. That's one part. Second part is P. P is what letter, ladies and gentlemen? It's the first part of your vertex, negative 4. So that tells us we are going to move left 4. And then Q. Q, in this case, ladies and gentlemen, is plus 9, or just 9. So that tells us we are going to go up 9. Now, ladies and gentlemen, transformations is something, if you haven't grasped it, I want you to spend a lot of time getting used to now, because we will be doing transformations most units of this course. We're just going to be dealing with different functions, okay? So we start with the quadratics because it's pretty easy. Actually, we started with linear a while ago, and then we're into quadratics, and then we're going to get into some harder parent functions. Okay, so please spend some time reviewing that. If you need help with that, again, come see me. E part, state the optimal value. So optimal value, another word for that is your min-max value. Okay, also state if it's a minimum or maximum. Well, first of all, we know it opens down. So if it opens down, think where the vertex is, it's going to be at a max. So we know it's going to be a maximum of whatever your Q value is, because it shifts it up. So it's going to be a maximum of 9. Okay, because the optimal value deals with your Q of your vertex. Okay. All right, state the step pattern in this question. Well, we know generally the step pattern is A times 1, 3, 5. A in this case is -3. So it's -3 times 1, 3, 5. So what does that equal? -3, -9, and -15. Okay, and let's graph this function. So again, to graph, it's easy if we've got the vertex. So our vertex is, ladies and gentlemen, -4 and 9. So -4 and 9. So we start with that as our vertex. And then we're going to apply the step pattern. So as I go over 1, I'm going to go down 3. 1, 2, 3. As I go over 1, I'm going to go down 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. And as I go over 1, I can't go down 15 because I won't fit it on our graph. So try the other side now. Over 1, down 3. Over 1, down 9. And because it's symmetrical, I can just put it right beside on the same line. Okay. Notice, ladies and gentlemen, how much more narrow this parabola is than the parent or base function. It's because we're taking it and stretching it 3 times its normal width. Okay, and let's put our equation on. Y equals -3, x plus 4 squared plus 9. All right, ladies and gentlemen, that's our warm-ups. Now today we're going to get into some mapping diagrams, and this is new stuff. Yeehaw! All right, lesson title 1.1, Relations and Functions. A relation, which we've been talking about, is a set of ordered pairs. Values of the independent variable are paired with the values of the dependent variable. And the independent variable, you should remember from grade 10, ladies and gentlemen, is freely chosen. Usually we pick values like -2, -1, 0, 2 if we're graphing on a Cartesian plane, or if we're trying to figure out, you know, the cost of holding a banquet or something, you might have 10 guests, 20 guests, 30 guests, 40 guests, 50 guests, etc. So you can pick those at any value, okay? And those are graphed on the horizontal. Whereas the dependent values, ladies and gentlemen, or the dependent variable, depends on the other, and it's graphed on the vertical. So for example, if you're talking about number of guests versus total cost, the total cost is going to depend on how many people you have coming to your banquet, okay? So just remember that, ladies and gentlemen, independent deals with the x variable, okay? Dependent is the y, okay? And so you may remember some of your teachers talking about input versus output. So input is your x value, and you plug that into the equation to get what we call your output value. And your output value is your y, because it depends on your x. Okay, now we're going to change, and most of this unit is going to be on, or this course is going to be on functions. So we're going to make a shift from a relation to a function. And how do we know when we've got a function and not just a relation? Here's our definition. A function is a special type of relation where each value of the independent x corresponds with only one value of the y variable. I will accept if you just write down each x has only one y. That's the easier way to do it, ladies and gentlemen. Okay? Mapping diagrams. How can you tell from mapping diagrams if it's a function? A mapping diagram, ladies and gentlemen, is kind of like a table of values. The only thing is if something's repeated, they just show arrows to it. They don't necessarily write it twice. Okay? So think about the first bubble being your x and the second bubble being your y. So what we need to do is take a look. Does each x have its own y or only one y to make this a function? So what you should say is, no, this is not a function, because when you take a look at when x equals 4, notice that, ladies and gentlemen, when you got x equals 4, for y it goes to 3 and to 1. So that means it shares two values. It doesn't have one. In this case, when x is 4, we have two values for y, so that doesn't satisfy our definition of a function. So no, this is not a function because each x does not have its own y. Let's take a look at the second example here. Again, this is my x and this is my y, or my independent and dependent variables. Okay, does each x go to its own y? Okay, so this x, when x is 1, it goes to -2. When x is 2, it goes to 3. When x is 4, it goes to 3, but guess what? That's still, each x has its own y. The y can be repeated, it's just the x that can't be shared to two of those. Okay? So in this case, yes, this is a function because each x has its own y value. All right? Great. Now, a great thing that's a good test to tell you if it's a function is what we call the vertical line test. And this is pretty easy, guys. This will be on your final exam as well. Vertical line test is a graph is a function if there is no vertical line that crosses more than once. So what I want you to do, ladies and gentlemen, is take up a ruler. I'm just going to quickly draw a stick here that I can move, okay? Make sure it's horizontal. So pretend that's my ruler, guys. And what you want to do is take your ruler, and to find if it's a function, it should only cross it once as you go from left to right. Okay, so for example here, if I hold it here, does it cross more than once? Absolutely, it crosses here and here. So is this a function? No, this is not a function because it does not pass the vertical line test. And on your test, you can still use, instead of writing vertical line test, you can just go VLT, vertical line test. Okay? I can take my ruler, go over here, and take a look at a parabola. Okay? As I go from left to right, it's only hitting 1 point. Because remember, folks, with a parabola, as you go up, you go out in both directions. Okay, so it still even will continue on if I go like that. Okay, so a parabola will always be a relation when it's either opening up or opening down. This is called a square root function, which is it's a transformation of that. We'll get to that later on. But for as far as the second graph, ladies and gentlemen, yes, this is a function because it passes the vertical line test. And you'll be doing similar stuff like this on your first unit test. Okay, ladies and gentlemen? So just imagine taking a ruler or taking your pencil and using that to help you. All right? Good. Now, the third part, and the hard part, I would say, the harder one, is when can you tell when equations are a function? Okay, so we got some equations, and you might recognize some, you may not, but what we want to think about it is if you can envision the graph. Okay, so when it says to think about it, what does the graph look like? Because if we can get it to a graph, then we can easily use the vertical line test to help us with that. All right, so let's take a look at example A. Example A, hopefully you recognize that relation as quadratic. Okay, so is that a function? Well, when we graph a quadratic, we get a parabola. And as we looked up there, does a parabola pass the vertical line test? You would say yes, because it would pass the VLT if graphed. All right. Taking a look at our next equation, ladies and gentlemen, B. So B, does anybody recognize what type of relation that is? Well, looking to the fact that there is no exponents, hopefully you realize that's a linear relation. Okay, and when is the only case, ladies and gentlemen, we got a linear relation where the linear relation is not a function? Well, I want you to think about it carefully. The only case is when you've got an undefined slope or a vertical line, and it's going to look like x equals something, like x equals 6 or x equals -2. Okay, so if I was plotting that, 6 would be here, and there would be your line. Okay, and if it was -2, it'd be over here. Okay, again, if I go to try to put my vertical line on there, they're hitting all the spots at the same time. So the only time when you have a vertical, when a linear relation does not pass a vertical line test is if it is a vertical line. And how can you tell? It's just going to be in the form x equals a number. Okay, so in this case, we know there's a slope and a y-intercept. So this is an example where, yes, this is a function because it would pass the vertical line test if graphed. All right, last example. Many of you may remember this, or some doesn't. Let's take a moment and think about that. I'll give you a hint, ladies and gentlemen. From grade 10, you might recognize this formula. Hopefully you remember that's a formula for a circle. So if you wanted to just take a look, ladies and gentlemen, what would the radius be? It'd be the square root of 16, so that would r would equal 4. So what does that graph look like? That means that you would do a circle, and it would hit at 4 and at -4. So looking at that, ladies and gentlemen, if I moved my vertical line test ruler over, would it pass it, ladies and gentlemen? No. Okay, because it has to be at all points on the graph. Okay, so this is a circle. And no, this is not a function because it would not pass the vertical line test. I don't know why I wrote it out. I just was thinking. Okay, you could put down VLT, no problem. All right, ladies and gentlemen, hopefully everybody found that okay. So today we're taking a look at when is a relation a function, and also remember, guys, if you need some help with completing the square, as I tell you, you need to have that mastered before the unit test. Please see page 564. There's some examples and then some questions as well. And also come see me as well, guys. Hopefully you enjoyed our second lesson. And today's homework is page 10, numbers 1, 2, 4A, 9, and 11. Have a fabulous day, guys. And I'll see you later. Bye-bye.